Hello everyone, this is Bradley. Today this is a voiced recording to make a lightning ball animation I was saying long time ago. It was done in Unity by drawing, but since we do not know how to draw, or I do not know, we are going to do this procedurally using geometrynodes. So let's start. So here we are in Blender. As always, I'm going to use the presets, which you can download for free from the link in the description. Basically, the idea or the method that we are going to use is that we are going to emit particles. And these particles will be this kind of curved line. And as we are displacing this curved line, we get this kind of lightening effect. This is the general principle. And to emit particles, there are basically two ways. One is you simulate the particle emission, or two, you fake the particle emission. The difference between these two methods are very important because recently I just got a complaint in one of my simulation nodes tutorial that you can fake it, you do not need to use the simulation zone or all this kind of math and so on. He's kind of right, but he's also kind of wrong because his comments or complaints can be generalized to all tutorials using simulation zone. You can always fake something, but fake is fake. It's not real. So it's bound with a certain limitation. And we always fake stuff before simulation zone came out. It does not mean simulation zone should never be made into geometry nodes. So you sometimes need to really decide whether you fake or really to simulate something. And today we are going to fake it because I am not going to focus on interactivity of a ball. The ball is basically just in the center of a view and it's shooting particles besides. But in other cases, if you are trying to put a ball on a character's hands and emitting particles, then you probably want to think about the simulation zone. Okay. So today, since we're not going to simulate, I'm just going to instance the point as a way to emit particles. So we're instancing particles without emission. Here, we're going to instance this kind of curved line. So let's take a curved linear. Yes. And then I'm going to orient this curved line 360 degrees. But I want it to be relative to my camera angle in this case, so that it does not go closer or farther to my camera. So the way I'm going to do that is to combine Euler rotation. And let's take a translate instance so that I can move that. I know where I'm oriented at. I think by orient on y-axis, then you can see this is how it will rotate. And we just take a randomness. And I'm going to use the variance only. And type in TAU on the variance. And use the radians. So now I have this instance being oriented 360 degrees at this angle. I can decrease the scale of this curve line, and I can increase the count. So you can see finally they form a kind of a ring. Up to this moment, this is very boring. So there are several things we are going to do. One is that we are going to animate this translation. And now they are synchronized. And it's kind of very boring to form a ring. I want them to follow kind of order. And the way I'm going to do that is essentially just to take a delay Falloff. This delay Falloff essentially is an index subtraction. So they're delayed by their index value. And by plugging this for, we have this step interval. This means from index 0 to index 1, you will be delayed this amount of time. So here we can increase this value, and the duration means how much time it takes for this for to complete from 0 to 1. Okay, so this is the idea. And we can remap 0 to 1 to increase the value of its completion, just for demonstration purposes. And by animating that, you can see this is the effect we are having right now. And we can increase the duration of it. The better part of this delay for at this moment is that we are making the duration for every line to reach their destination, but I don't know how much time it takes overall for this animation to actually complete. Most of the time I just eyeball it. So right now it takes like 200 frames to complete this animation, which is kind of okay. Right now they are not really going in a perfect order because we are already randomized their rotation and order in this case. But in other times, if they are following a specific order and you want to randomize this delay on the index, you can take it in index randomize, and you take this new index to it, and you can set the targets and so on. Right now you see it's not really working properly. This is because we are working on the instance. So this domain should be set to instance. And now you have this kind of weird whatever stuff. You can see they are overlapping and it looks kind of very nice. Yes. If you do not index randomize, you probably can do the index converge so that multiple of index will be emitted at a certain time. So whichever way you choose, these are just different ways to accomplish it. Okay, so now we have this basic emission animation being done. Next step is just to delete all this kind of stuff and displace them. So one thing we are going to do here is to scale the instance. This also helps to delete this instance when they haven't been animated yet. So basically, we are going to float curve this fourth, which is going from 0 to 1. And before this animation starts, they should have a 0 scale. And after this animation finished, they should have a 0 scale as well, so that the particle is basically being killed when they are not being animated. And this is basically what we see. But you also realize that this scale is essentially affecting the translation somehow. So we probably scale that after the translation. So now we see this kind of, actually this kind of looks very interesting. It looks kind of wavy effect. Like a kind of a sound wave being spread out. I think this thing by itself is already kind of interesting, although I'm not sure how to really make it practical. But it looks kind of interesting to me. Anyway, let's increase the duration a little bit for me to actually visualize things a little bit better. Maybe the step interval as well. So now we have a kind of a slow sound wave-like animation. And then we are going to realize this instance because we are going to displace that with the set position. You can take a noise 3D. Then it will displace everything on 3D space. And by playing this animation, you can see this kind of wiggling, jaggy, whatever stuff. We are going to put a different seed on every of them. So we can take a spline info so that every spline has a different seed. So that we can increase the frequency. And it looks like something like this. And sometimes the lightning effect should be kind of jaggy. In this case, it's actually about the resolution of this whatever stuff. So sometimes you can decrease the count either before or after by using the resample curve. So whichever way you can, whichever way you would like to do, it's kind of okay. Or sometimes you can even decrease the resample curve afterwards. It also sounds to be kind of interesting. I think the benefit of a new resample afterwards is that you can have more resolution of noise, but then you make the jagginess more prominent. But anyway, this is kind of idea. Yeah. So we are going to make these lines into an actual volume, and we're taking the flat profile. So now you can see they're looking kind of very ugly because every time you're changing the tilt and the normal of the curve. So we take tilt alignment to make sure that this tilt is always looking at the camera. So now this is how it looks like. Okay, and definitely we need to shrink the radius, take value positions, so something like that. You can also set a curve radius. We're going to take a spline parameter and float curve top in the middle, so that you have this kind of stroke kind of curvature. Okay, so you now have this kind of effect. I'm kind of very serious, even if you may think this kind of very ugly and whatever weird thing is going on. Or another thing that you can actually do is, instead of scale that, sometimes what you can do is to use that to affect the radius we have. So now we have this radius and we remap 0 to 1. And remember to really capture this delay for our instance domain. Otherwise, you will have conflict of this index randomize. So now we capture that onto the instance domain so that it can be realized together with the realized instance. So now you can have this effect. Probably not really a good idea, but you probably see what I actually mean, that it becomes thinner and thinner when it completes the animation. So this is up to you how you decide to really design this effect, but actually you can combine them together or not, whichever way you would like to do. These are just the different ways to work. Okay. And sometimes for lightning effect to occur, you will see a kind of flickering of the effect. So one frame it shows up, the other frame it disappears, and another frame it shows up again, and so on and so forth. If you want to mimic this effect, there are plenty of ways. It depends on how much detail you want to put. One thing I want to remind you that there is a show in render node, and you can disable that. Okay. This node essentially is using a switch. So by switching on and off, you are making an animation disappear and appear. The downside of this switch is that it does not take a field, because if you take anything like a position node then you will find that there's a red linkage. So this actually means that if you do not have a general control, instead you want to control for every spline in this case, it means you need to use something like separate geometry or delete geometry in this case. And we're going to delete before this curve so that we have literally a domain of this spline. And we're going to use a modulo Falloff. This modulo Falloff contains a time component inside. So as we scroll on the timeline, this modulo Falloff is counting the steps to output the true or false. So in this case, we just put in true, and you will see any effect it's flickering very fast because it's flickering every other frame. Let's take that into 4. Then it becomes more obvious, whatever stuff. So this is the same as you are doing with the showing render. They're the same because this is not a field. But the benefit of this separate geometry is that you can put a different offsets into them. So for example, you can take a spline info to take a different offset, and you can see actually the difference between two. Anyway, so now actually every of them are supposed to have a difference if you enable this separate geometry. It looks kind of very chaotic. It doesn't really look very nice. So let's disable that. I think this is good enough. We just tweak the parameters. Okay. You can also change the threshold. But in this case, it probably doesn't really make anything better. Anyway, it depends on how you actually see the stuff in the final results. I don't know. Okay, so these are just different options. Whether you are going to do that or not, it's up to you. So now we have finished the basic setup and the main concepts of it. The rest essentially is just about the duplication of this effect to make different variations. There are many different possibilities. So for example, I'm going to point instance the same curve linear. Basically, I would like to, instead of shooting these lightnings away, I would like to make a static lightnings on the center of this water origin. And here I'm going to take a random rotation. And we can see we have these splines in the middle. I'm going to realize instance, set position, take a noise 3D, give different spline a different seed so that they will not be displaced as a whole. I also would like to increase the resolution because our initial curve count is just 3. So just a resample curve, add enough vertices you want, and then increase the frequencies so it becomes more like kind of lightning. We can take a set curve radius, and to visualize the radius change, we're going to take a bevel curve. And here I'm going to use another noise 3D, plug that into the radius. So now we have this kind of lightning radius. We can decrease the scale. But what I'd like to do is that I want to make it a thing at the start and at the end. So we basically use the same spline parameter and this remapping to both noise texture so that we have less displacement and less thickness in the middle. After we've done that, we can just duplicate another delay Falloff. But remember, this delay Falloff is using the instance domain. If you do not want to duplicate that, then we can try with another capture. Because once we realize the instance, then we will lose all this kind of instance domain setup. So I'm going to multiply this delay Falloff with these values, whether it's a radius or noise, but I'm only going to affect the radius. So that's all splines disappeared, but you can see that as the animation goes, they appears. And what I'm going to do here is I'm going to remap this Falloff, so that it will appear and disappear. Let's decrease the overlapped result. Maybe only repeat the target like 1 or 2, change the seed, so that we have this lightning showing and disappearing. Okay. And we can change the duration as well if you want, so that yeah, maybe 3. You can all tweak these different settings together, and once we completed that, we can just join geometry. So now we have multiple setups. One is emitting outside, and the other is centered in the middle. You can tweak some settings to change the minimal emission amounts. So now we have different setup. Okay. I'm also going to do the third types of lightning. So again, we are going to point instance with or without the same count. And here I'm going to also random rotation, but I'm going to change the seed so that they look a little bit more different. Probably will duplicate a different curve linear, because this time I only want to these lines straight out without being centered. Okay, and then we basically do the same with the translate instance. Let's remap that so that you can see how it looks like. We are moving on the x-axis so that you can see they're getting out. We take a delete Falloff, index randomize, take the Falloff, combine XYZ, remap 0 to 1, and we realize instance, set a position, set curve radius. It's basically all the same, but we are still going to duplicate different values. So that potentially we can use different parameters. Just to remember that we are using delete Falloff to multiply with this Falloff, but now we are working with a different geometry, so you have to duplicate this multiplier to something else. We can capture a value before, and then we multiply with new one, and then we plug that into the Falloff to replace everything. And of course we need to resample it, something like that. So now you can actually see this lightning is going out. We can increase the step, change the domain so that we're emitting 1 by 1, and so on and so forth. The different part I'm going to do here is that I'm going to increase the scale. Okay, so that you can actually see how this lightning is going. Another thing I'm going to do is that I'm going to, let's say, translate the position of this noise, and we can capture the position attribute of this curve linear. If we use this captured position, then you can see when you're translating, you will not displace yourself. otherwise you can see when you translate, you will also displace yourself because the position is moving. The position of the noise texture inside is using the position value of your current moment, which is moved by this translate instance. That's why you capture an attribute to stabilize everything. And instead you can move that, use your other translate nodes to move on the X and Y. So this way it may make the displacement more predictable. As you can see, the kind of direction is basically in the direction of movement. I'm just going to take a time info node to drive it. And we can decrease the deviation factor. So it becomes something like that. And you can take a bevel curve. So something like that. And we take a float curve remap so that it does not only go out, but it also disappear itself as it goes out. Okay, and then you just increase different values, increase the length, increase the subdivision, and you can add the flickering as I mentioned earlier. So we have the separate geometry and the modulo Falloff. So you can add all this kind of flickering. You can also add the displacement a little bit more. And then we increase the sample amount. So something like that. There are many different possibilities and parameters they can do. The reason I currently do not make them into an actual preset is because I think there are many different possibilities, and if I make them into an asset, then we lost many of the possibility. And there are lots of parameters that if you make them into a node group, then it will be a huge long list, whatever rectangles, and so on. So anyway, so there are many different possibilities. I'm not sure the final results you will see, but I hope you like that and enjoy that. And you can also emit the flat profile and the tilt alignment. Okay. So this is basically, oh, we should put the separate geometry before this curve so that we can see this kind of fast flickering, whatever stuff. So these are just the different options. You can try to investigate all these kind of values, tweakings by yourself. So I hope you enjoyed this video. I'll probably see you next time. Bye bye.